Okay, for this video, we're going to find vertical, horizontal, and oblique asymptotes if they have any for this given function. So our function that we have is f of x equals 12x squared plus 7x minus 10. This particular rational function is considered to be improper because the numerator, the degree, is larger than the degree of the denominator. So the first thing that we want to do is to see if we can simplify. So we want to look to see, can we factor the numerator? So to do that, the easiest way to do this is if you take 12 times negative 10, we end up with negative 120, and we want to see, are there factors of negative 120 that add up to be the middle number, which is 7? And I know that this can be troublesome, so it can take you a while to find this. Any factor that is a factor of 12 or a factor of 10 is also a factor of 120, and also the products of any factors. So the one that I'm going to start with is 15, just because I already know that it goes into there, but this factors into 15 and negative 8. Are the two values. If I take 15 times negative 8, I get negative 120, and 15 plus negative 8 gives me 7. This is the easiest way for me to factor. If I'm trying to factor things, I look for what two numbers multiply together to give me the product of the first and the last term that also add up to be the middle number. So with this, now what I want to do is I want to take and I want to look at the first value here, which is 12. And I want to look at these values here. Basically what I had to do is I had to distribute some number to get 15 in order to add it together. So I want to see, what do 12 and 15 have in common? And I know they both have a 3 in common. So if I take that out of both of them, I would end up with 4x plus 5. And then I want to do the same thing with the 12 and the negative 8. The 12 and the negative 8, the largest thing that they have in common is a 4. So if I take that out, I end up with 3x minus 2. And if we look at this, 4x times 3x gives me 12x squared. The 4x times the negative 2 gives me the negative 8. The 5 times 3 gives me the 15. That add up to be 7. And then the 5 times negative 2 gives me negative 10. So we can see that I can simplify this. So we want to simplify it. And when we do for this particular one, it simplifies down to a linear equation. So when we're talking about the asymptotes, we want to go through all of the rules of asymptotes. The first one is vertical. In order to have a vertical asymptote, what has to happen is once you've simplified it, it's whatever's left in the denominator. In this case, because when we simplify it, we do not have a denominator, we can say that there is none. We can see that there is going to be a whole at x equals negative 5 over 4. And where that came from is, remember that the denominator of the original function cannot equal 0. So since this cannot equal 0, if I were to solve it, I would move the 5 to the other side, which would give me negative 5, and divide by 4, which would give me negative 5/4. So this one does not have a vertical asymptote, it just has a whole at negative 5/4. The second one that we want to look at is a horizontal asymptote. In order to have a horizontal asymptote, what has to be true is the numerator, the degree of the numerator has to equal the degree of the denominator, or the degree of the numerator has to be less than the degree of the denominator. So if you look at this right here, 2 is larger than 1, so the degree of the numerator is larger than the degree of the denominator, so it does not fit the criteria for a horizontal. So we can say that this one is also none, since the degree of the numerator is greater than the degree of the denominator. In order to be horizontal, they have to either be equal to each other or less than. So I will discuss that in another video, but for this one, it does not meet the criteria for horizontal. As far as an oblique asymptote goes, an oblique asymptote is if I were to take the denominator and divide it into there, if it has a remainder, then we have an oblique asymptote. In this case, the oblique asymptote would line up with the line, so there really is no asymptote in this case, so they consider it none, since we really have a linear function. So even though in this case, if we were to look at it, it does look like it's oblique, because the rule for oblique, in order to have an oblique, the degree of the denominator, or sorry, the degree of the numerator has to equal the degree of the denominator plus 1. So it has to be 1 more than the degree of the denominator, which is the case here. So had this not been able to be simplified, if the 4x plus 5 was not in common with the numerator and the denominator, then whatever I got when I used long division would give me the oblique asymptote. And so for this one, we can say that there is no oblique asymptote because of the fact that this ends up being a line, and the oblique asymptote would not be able to be differentiated from the line, because if I divided the 12x squared plus 7x minus 10 by 4x plus 5, there is no remainder, so it's a factor, so it goes in evenly. So with this, just to recap, you have a vertical if the denominator can't be simplified and it's whatever makes it 0. But in this case, since it can be simplified, we don't have one, we just have a whole. If, in order to have a horizontal, the degree of the numerator has to equal the degree of the denominator, or the degree of the numerator has to be less than the degree of the denominator, so since it's greater than, there is no horizontal. And the oblique, since it goes in evenly, we just consider it not having any. So I will do other examples where there are vertical, where there are horizontal, and where there are oblique. As always, thanks for watching. If you have any questions, please let me know. If you have any other topics you need me to cover, please let me know that as well.